Hi Cashew Nation, I'm Engineer JD, a structural engineer and a college and review center instructor. And today, we will discuss about integrals. So let's get started. In this video, we will calculate definite integrals using the Casio FX570ES Plus 2nd edition, and we will present it again in two ways, the Math IO mode and the Line IO mode. And then, we will talk about how to calculate improper integrals, again by this calculator. Calculating definite integrals in this calculator is very simple. We have this key, which is the integral key. This is here to be able to calculate the Math IO mode integral of the expression. Now, in the Math IO mode, you will see something like this, which has three boxes, and each of these three boxes require three parameters. In the integral, you have the smaller two boxes. The one at the above is x equals b, or the upper bound, and then the box below is the lower bound, which is x equals a. And then this larger box to the right is the integrand, or the input function f of x. Now, to be able to display it in Line IO mode, to calculate, we will press again Shift Mode 2 to access the Line IO mode. And then, pressing again the integral key, you will display an integral function like this. Now, this integral function here requires four parameters. First is the input function, or the integrand. Second and third are the lower and upper bounds, a and b. And the fourth input is the accuracy. Like derivatives, the closer it is to 0, the more accurate the results will be. The less nearer it is to 0, the less accurate the results will be. For improper integrals, they are specialized form of integrals in which one of the bounds are unbounded or towards infinity. Another case is that improper integrals have an undefined expression within the interval of the bounds. Now, to be able to calculate that in the calculator, we will make some approximations. First, whenever we see infinity in the integrals, we will use a real number that is very high or very low. For example, if we have a positive infinity in the integral, we will replace that with something like 99 or 999. Any number that you like as long as it's large. And then, if you encounter an expression that has a value of x which is undefined at a certain point within the interval of the bounds, then we will have to split it when it is between these two bounds. As shown in this case 5, we will split it. Now, if this undefined value occurs within one of the bounds, either it's in the lower bound or the upper bound, then we will have to approximate it with something that is very close to that, but not equal to that number. For example, if the expression here, for example, 1 over x squared is undefined at x equals 0, but in case 3, we have this lower bound which is 0. So we cannot calculate improper integrals. It will show a math error in your calculator. Instead, we will replace 0 with something very close to, but not equal to that 0. For example, 0.0001. Now, let's show it in the examples. First, let's find the area of the shaded region in the figure below. We have this circle of radius 6 meters, and then we cut a segment which is 3 meters high, and then we will calculate the area of this segment. Now, of course, there is a direct formula for this, if you recall, but for this purpose, we will show the calculation of this area using integrals. Specifically, we will calculate it using vertical strips. So we have this vertical strip that encompasses the height from the bottom, which is y equals to negative square root of 36 over x squared. That equation, it's because the equation of the circle with origin as the center and radius of 6 is x squared plus y squared equals 36. Solving for y and then taking the bottom semicircle, you will get this y. And then we have this line, horizontal line, which is 3 meters from the bottom of the circle. We can now label that as the line y equals negative 3. And then let's calculate the integral from left to right by taking vertical strips and then adding them together. Now let's solve the intersection of this line and the circle. So to press that, we have negative of square root of 36 minus alpha x squared. Alpha equals negative 3, and then shift calc. We have this input value of x. Let's press 4, and then let's press equals. We do the shift solve, and then we get this value of x, which is 5.19615 as the value of x. And because in the figure it's symmetric, we get the minus sign of it. So we have negative 5.1961 1 as the other root of this equation. So here, x is plus or minus 5.1961, or in exact value, it's plus or minus square root of 33. Next, let's input that in the calculator, the integral of this expression. So we have integral, and then for the lower bound, it's the left side of the intersection, that is negative square root of 33. And then for the upper bound, it's the right side, which is square root of 33. And then for the integrand, let's input upper minus lower. Remember, we are taking the vertical strips, so we have to subtract the upper expression minus the lower expression, which is negative 3 minus the square root negative minus negative square root of 36 minus x squared, and then close parenthesis. And then let's close parenthesis again and then open at this part. Now we have this full expression for the integral. To calculate the area of this expression, if we press equals, you will get this 21.4888 square unit, and that's how we calculate the area of this expression. Now this is in Math.io mode. How about the Line.io mode? So press again AC. Let's go to Line.io. We have shift mode and then 2 for the Line.io mode, and then let's input again the integral. So here we have the integral, and then input the expression negative 3 minus negative of square root of 36 minus x squared, and then comma, shift parenthesis, we have this comma, and then the lower bound is negative square root of 33, again shift close parenthesis, that's comma, upper bound is square root of 33, last shift comma, and then square root of 33, and then last, the accuracy of the solution, which is, let's say, 0.0001. Now this is the full expression in Line.io mode. Let's press equals. Now you will get the same answer of 21.4888 square unit. Now if you try to make it less accurate by reducing the accuracy, the part which is at the lightmost changes, but till the first 4 decimals at least, they are accurate. So that's it for the calculation of integrals using Casio FX570 ES Plus 2nd edition. And that's it for today. Thank you very much, and see you on the next video.